Historically, creating and maintaining isolated environments for developing and testing software has been a challenge for most organizations. It is a need in order to protect your production systems. However, it comes with significant technical and labor cost, as well as security risk. Today with me, I have Kevin Hartman, Partner Solutions Leader at Databricks. He comes from a software development background, so he is the right person to talk about the development experience with Databricks' Lakebase, which solves for these problems in an agentic era. Take it away, Kevin.
Well, thanks, Joshua. I really appreciate the time you're affording me to talk about this topic. So let me first set the stage and with what the world looks like today and we're on the database for a typical engineering team shipping a real application. Today, it looks like a lot of databases. You've got production, you've got staging, UAT, a separate database for the QA team, maybe a shared database for engineers that they fight over if they're lucky. Each one is running an instance. Somebody has to provision it, patch it, monitor it, back it up. Every one of those is a place where things can drift or break or quietly diverge from production. And every one of those costs money. And every one costs engineering time on top of money. And the team spends real hours just keeping this fleet alive. And then when it's time to actually ship a database change, like a schema migration, a new index, there's this little dance. This goes down, you run the migration, hope nothing breaks, and if it does, you got to restore from a backup from another system. Usually it's 2 a.m. on a Saturday, and you don't want to do that. The reason why it looks like this is because there's something underneath that cost story, and that's the fleet exists because you can't really iterate on the database in the same way that you can iterate on code. Application development is iterative. You don't design everything in one go. You develop a feature, add to the code base, reflect on what works, what doesn't, refine, and you could discover more features along that way. And the code itself needs agility, to refactor with confidence that you didn't break something, and to refactor with confidence, you need an abundance of tests. Half of the code that I write isn't actually code that goes in production, it's the tests. Refactoring a database has been fundamentally harder than refactoring code. You could branch your code and merge it back. You couldn't branch your database. So the fleet of databases that is what the teams built. They built those out because the database couldn't keep up with the code refactoring, and the tests couldn't run against the real shape of data. The fleet is a symptom. The real problem is that database refactoring has been slow and risky, so teams built parallel environments to protect against that risk and built mock objects so tests could run at all. So this is what the developer workflow looks like today. This is what it looks like after. Lots of things disappear when you can branch your database. And until now, you couldn't. When you can refactor your database and it becomes cheap as refactoring code, the workflow collapses. All the things I had to do, the concerns, creating mock objects, they come out of the test path. I can write real integration tests directly against my data. And that sort of shared staging environment stops being a contested resource because now I could just take a branch anytime I want to. Integration tests can run against production shaped data on a per PR branch. Any feature you're working on, any tester that wants to go and do additional tests or user acceptance testing. So that compensating layer that was this load-bearing thing for 25 years isn't load-bearing anymore. So this raises a question that maybe should be on top of your mind. If branching makes this go away, why is this new? Why hasn't this been talked about more? It seems like a big deal. Well, the honest answer is this developer loop story that's been broken for so long that engineering teams don't know and don't expect it to be fixable. This Agile manifesto, I don't know if you've heard of that, it was signed in 2001. And since then, every part of how we ship software has been refactored for short cycles, CI/CD, ephemeral preview environments, GitOps, the whole stack, except the database. The database accretes changes slowly while everything around it ships daily. So for 25 years, we've just compensated. And that compensating layer has become foundational methodology. And we've developed workarounds. And I've been working closely with engineering teams and agile development teams and thought leaders and the people who had shaped how the industry thinks about this agile database practice. And their read is the same. Database branching is the missing piece, and it's the last gap that the agile playbook couldn't close on its own.
While that was very straight and to the point, I think I like the practicality of demos. So go ahead and show us the demo that you have for us today.
I would love to show you a demo. Okay. So what I have on my screen right now is my VS Code environment. And if you're familiar with this environment, you may notice that there's something different. Normally, I have something called a source control view where I could see all of my code that would be synced up with GitHub. What I have instead is this Lakebase SCM extension. And what this does is it pairs my database branch, Lakebase branch, along with my code branch. So you can see here I've got a number of code changes that will be submitted in this branch when I do submit and do a PR. And I've got some database changes here as well. And I can see that these are different from what staging has. Staging has just these tables and it has also some different code. Now, I like to show you that I can look at this in multiple ways. Another way I could look at this is a very simple view of looking at everything that might be submitted together in my PR when I do my final merge into staging. Now, keep in mind, I'm working on an isolated branch here. This is totally independent and different from what I have running on staging, the staging environment. And to showcase a little bit of that, this is my application that I'm working on, and my feature branch has a new difference in what I would be submitting here. So currently, this is a tool, a tracker for uploading assets to Databricks so we can review them. So if I have ML routine demo, something like this, and I could then specify what this is, ML modeling, and it's a notebook, and maybe it's a demo, okay? And then I could submit that asset. All right. What I'm going to do, though, is I'm actually not going to do anything here. I'm going to switch branches back to staging to show you what the differences look like. So you may notice as I switched that I now have a different form. This is actually coming back from code. I've just went back into staging and pulled the code back. Let me go back into there. And the form actually changed beneath me. Right, before I had a multi-select field or a multi-select capability. Now it's freeform. So that's something I was doing in this particular branch. Is I was changing the way that that looked and behaved. I can see then too is I've got this branch diff summary that's totally different. And this branch diff summary is showing me what staging looks like versus production. And it doesn't have any schema changes, maybe it's a few code changes. So you can see how things really look. And I can very quickly decide, oh, I don't know if I really want to go with this particular one. Let me actually do another branch instead. And I can very quickly say create new branch. And maybe I'm going to do it from staging again. So it's going to be different feature, parallel A/B test, because I actually want to try out a couple of different scenarios with my product owner. And maybe that's not the one I really want, or maybe that's something that he doesn't know if he wants. So I can very, very quickly create another branch from staging. And this is a pristine environment. This is totally isolated, and it's ready for me to go ahead and start doing my development and my code. Okay, so let me share with you what just happened in the demo, looking at it role by role. So when your database can branch like Git, the engineering workflow changes for 6 different perspectives, right? For the developer, I get days back each sprint because nothing's waiting on a shared environment. For the tester, their own real data branch they can get in seconds. So the shift lefts actually can legitimately work. For compliance, I have Unity Catalog, And that's where I have policies that can travel with each branch. So one posture for security, your security model, not multiples. I could apply at the top level and inherit that all the way down. For a platform team, the staging logic, all the mock object scaffolding, all that other stuff that I had to do to set up my environments, that could also come out because the database can keep up now. And it's just one production instance with multiple instances as branches below it. For an engineering manager, integration issues are caught during development, not after deployment. For the leader, it's one database to govern and pay for instead of a fleet. 6 different type of roles, one capability. That's the unlock.
What does this mean for AI and AI agents, the fast development and iteration of software today?
Josue, the answer is pretty simple, right? Because what's good for humans in the human workflow is also good for agents. And agents need isolated, governed environments to operate safely too. And branching is their substrate. Agents can write tests, and they can do them against a real Lakebase branch, not synthetic mocks. And you really don't, you want them to do this because you don't, against real tests, because you don't want the AI slot pattern where agents, claim they're done, but they actually never ran against a real database. And the tooling layer is something that we need to create for the agent interface, whether or not our teams realize it or not. So we need our methodology to combine these constructs together. And when the developer experience is good, then the agent experience can inherit it. It's the same dev loop, different practitioner. So, and by the way, this is sort of late arrival, but I've been working on a Lakebase App-Dev-Kit for your agents to follow along and do the same methodology that I just shared with you on how I do the synchronization and how I can do these tests in a way that keeps things together. And the kit packages the different workflows. So I've got paired branching in sort of the source control domain. I've also got another parallel workflow that operates against it for test-driven development. So I can now operate on that construct and look at it from TDD, and that's a software development methodology that is now enabled by keeping these things together. It's one interface. It's the App-Dev-Kit. It's the same interface that the source control management feature in the plugin I just shared with you operates from. And now there's one for your agents to use too.
So basically, plug and play, work on the actual development of your software, and the goal for Lakebase is to be there, yet not to be there, if you will.
That's right. Right. Behind the scenes. And Josue, if you're going to Data and AI Summit, I'm actually going to be speaking with Promote Satellage, and we're delivering a session on this very topic around enabling evolutionary database development with database branching. And I hope to see you there.